recently, as I began to think about the next steps in my journey with Linux technologies and technologies in general, I was wondering about graphical user interfaces. I'm pouring myself some coconut water, and I'm going to mix in some cocoa into this flask. And I was thinking about graphical user interfaces. So I'm going to look at 6 or 7 different programming languages. Now, when I go on the web and I look at how many programming languages exist, I come up with well over 1,000. There's a lot more than 1,000. I come up with quite a few of these languages, right? And what I see is that, yes, there is a computer programming language out there for every season and every reason. And the thing of it is that, be careful with cocoa, by the way, because it gets all over everything, and it stains very well, but it also washes out very well. There's a programming language for every season and every reason. And a person does not necessarily need to learn all the programming languages that are out there, nor necessarily need to become adept with so many programming languages like we did in the past. In the past, the exposure to 20 or 30 programming languages was a good way to develop yourself in terms of how to think through problems, how to think through solutions, how to design your programs and your processes in a variety of ways using a variety of concepts and thought patterns. But the thing of it is, with artificial intelligence and even if we took artificial intelligence off the table and we said, hey, we have tools now in 2023 and beyond, right? Because I believe 2020, 2021 was a huge turning point in programming tools, frameworks primarily, but programming tools in general, that productivity is almost a given no matter which mainstream programming language you choose. So you can be productive with the programming languages I have written down here, right? I've written down quite a few programming languages that I've been thinking about, and as I go along this thought process, it will become very clear why this is such a huge topic, right? So I got 1, 2, 3, 4, 5, 6, 7 mainstream programming languages. And obviously I left some off, I left some other mainstream languages off this discussion, but the choice you have before you is, do you build software programs that serve a purpose and that requires maintenance within a narrow time frame or a long time frame? To me, that's what it really comes down to. Short term, long term. And so I see many programming languages that they exist to help move a concept or an initiative or a project forward, and do so in an expedient way. So you have expediency. You have the occasion to meet the opportunity without paying the cost of having to wait for the final result, for the final product or solution. You can get to market sooner and earlier, but there's a trade-off. Then you have programming languages and frameworks and approaches that are not necessarily expedient, but they line up with a long-term vision. They line up with longevity. They produce a digital solution that you can tailor, tune, and sustain with lower churn costs over a time span measured in 10, 20, 30, in some cases, 50 years. So I've been chasing in my personal projects, right? I always like to say that in all these discussions, there's a difference for me when I'm talking about personal projects and I'm talking about professional projects. Professional projects, in many cases, the time frames are short term and they're near term, and you benefit more from choosing expediency. That's practical, good business judgment. With the temperature out here, you see how this looks. It's actually in a very comfortable mixture here. So but for certain projects that need to stand the test of time, projects that you want to endure whether you're in this plane of existence or not, projects that whether there are future contributors to the project or not, it can stand on its own and it can go to distance in terms of its value and its usefulness and relevance to the times present and in the future. And there are many programs like that. There's at least 20,000 programs like that. You look at some of the Linux projects and some of the Unix projects. I know you're probably, if you looked at my videos, you used to me using the word Linux. Well, in this discussion, I'm actually talking about everything now. I'm talking about Windows, I'm talking about Linux, I'm talking about Unix, I'm talking about mainframes, I'm talking about embedded operating systems, I'm talking about it all, right? And so, but I start with the Linux and Unix worlds because they are the prime progenitor of a lot of what we see in terms of technological growth and technological evolution. Take a program like TAR, T-A-R, stands for Tape Archive Utility, right? It was designed for tapes. Back when, well, I shouldn't say back when, but you know, you had data backed up to actual tapes, and some places still do that. I know some people are used to the word Elgato being synonymous with video streaming hardware, but there's also an Elgato that was a company or a product that was tape, high performance industrial grade tape, designed for heavy duty backup and long-term storage. Well, anyway, TAR as a program has been around for a long time. I believe it even predates Linux itself. But there are many such programs out there where you don't necessarily have to rewrite the source code every 6 months to 2 years. You don't have to rewrite the source code every 2 months to 6 years, or even every 5 years. You can write the program over a very healthy development cycle ranging from 1 to 2 years that you spent working on it, maybe 5 years. But then when you're done with it, that program is rock solid. It's ready to go. And it can be used dependably and reliably in a wide range of situations, right? In my corporate life, I wrote programs like that as the backbone and foundation for the more complex web of solutions that I would layer on top of it. That's my software development approach in a nutshell. Building subsystems, smaller little subsystems that produce a little bit larger subsystems, you call them microsystems, and then a larger system substrate over that, which you would call a compartmentalized subsystem that has a general single responsibility, but it has multiple functions within it. And then you interrelate multiple subsystems together, and then you have an overall system. In a business environment, that's typically what I would do, because that would give me maximum reusability, maximum maneuverability, and ability to pivot an entire range of systems, GUIs, middleware, backend, all of that. I can just pivot that stuff. If I wanted to change the little foundation, just a little seed here, it would ripple throughout the entire landscape in a controlled way, where I achieve the objectives of performance, maintainability, the ability to monitor the systems and divert it in a certain direction. And so that's kind of a tangent, but the thing is that when you think about programs, right, they are both a representation of ourselves, but they are also a way for us to unfold possibilities and manifest new capabilities, make things happen, shift things, shift our time, shift our efforts in a more productive direction. And so I feel and I know that if we spend less time regurgitating the same programming languages, or let me say that in a much more clear way, if we spend less time redoing and remaking the programming languages and frameworks, and instead have solid frameworks and programming languages that can serve all purposes, and we can build software programs that use a fraction of the RAM that many of them do, and use resources in the computer more efficiently, and those programs are so solid that they can endure over multiple years and decades, then I know that we can achieve greater innovation. We can, because you slow down your innovation, and you slow down your productivity chasing productivity. So I could keep talking about that, but I'm going to cut and move on to the main topic, which is programming languages. I had intended to actually have this discussion back in January, I believe, and I actually did record something, but I decided it just wasn't the time for that. I needed to finish the other project that I had finished last week before I was ready to talk about this, because it was like first things first. So I want to go down this list, because the way we look at programming languages has an impact on how we're going to be able to address the problems of tomorrow. You can incorporate large language models and machine learning all you want, but at this stage of development in the human enterprise, humans will play a principal and active part in moving the solutions forward with or without prompts to a large language model, and you're going to do so with a programming language, right? So, C#. C# is a language from Microsoft that Anders Heidelberg created. Anders Heidelberg came from Borland, where he worked on Pascal. My father liked Pascal, by the way. But he worked on Pascal tools, and then Bill Gates, and I'm being superfluous with my language here. I mean, he went through a HR hiring process like everybody else, I would suppose. But let's just say Bill Gates hired him. And so he created the C# programming language, and it was modeled after and took inspiration from Java and C, right? Java and C. And so C# is, in my estimation, having used it for well over 20 years, and let's put an emphasis on the well over part, so well over 20 years, right? If I were to be precise, I would say it's going to be 23 years exactly in a couple of months. So anyway, so C# was designed to allow a programmer to write complicated, intricate codes quickly and do so with the same reliability and repeatability that you get from more established languages of the time, such as Java, such as C++, right? And so C# allows you to do that and do it quicker and better. And it was designed to supplant Visual Basic. Okay? Now, that's just a little bit of history. It's not even a complete history. There's a whole lot more to C# than what I just alluded to. Those are the broad themes that resonate in my mind. What I want to break this down into is C# and GUIs, desktop GUIs, and C# and web development. And again, if you follow this conversation, it will become clear when I get to the final programming language why I bring these up. C# and desktop GUIs, in my estimation, is designed to cater to Microsoft Windows first and foremost. Now, I know we got this new framework out called MAUI. I believe it stands for Multiple Application User Interface or something like that. But anyway, it has a little bit of the seed origin from Xamarin, which in itself was seeded from Mono. You have a programmer by the name of Miguel de Icaza, who's a brilliant programmer who wrote a clone of .NET for the Linux environment. And Bill Gates was able to lure him out of that situation, and he poured his energies into Microsoft, and you ended up with Xamarin, and then you ended up with, well, I think he had Xamarin before he joined Microsoft. He had this company, but long story short, Microsoft, buys everything, right? And so bought out that whole thing. And so anyway, but it's still focused on Windows. So if you want a toolkit and a way to build a desktop program on Windows in the shortest amount of time, that uses Microsoft best practices, that allows you to get access to a large array of features and build a very competent program, then C# and the desktop frameworks tied to .NET is going to be the way to go. Now, Microsoft has evolved .NET so that you can do desktop programs on not just Windows, but you can do it on Mac OS. You can also do it on Android and iOS. And I know we call them mobile apps, but mobile apps is actually a form of a desktop program. The principles, the way the rendering, the way the apps are activated when you tap on them on the screen, it's the same thing as a desktop program. So I'm at home with both of those, right? Because I really like desktop programs because I like the immediacy of them, right? They're rapid, right? When you click on something, it takes place right away. When you click on menus, and when you, in a more sophisticated program, when you're doing things and you're going through different screens, right? You're not waiting for a network response in many cases in a classic way of doing it, right? So I like desktop programs for that reason, right? They're my favorite. And so I like mobile apps for the same reason. Web applications, though, have traditionally been my forte because my experience with GUIs start with web development in the 1990s. So it predates my involvement with desktop GUIs. So C# in web development is also a great choice because, again, we're talking about stable, steady, structured software development that is somewhat rapid. It's not as quick as some of the others that I'm going to talk about, but compared to some of the others I'm going to talk about, C# is right in that nice middle where you can get a somewhat accelerated pace in your software development without going so fast that you break everything and you're unable to produce a solid solution. So ASP.NET Web Forms, ASP.NET MVC, Razor, and now Blazor, and all these things that we have in the .NET universe to build web applications that now can run on Linux servers and BSD servers and potentially mainframes. It's great stuff. It's great stuff that we have there, okay? Then we move on to Java. Java, the story is the same as with C#. It's the same story. And Java came from Sun Microsystems, and then Oracle bought them out. And then there was a little confusion for a few years there on APIs, but the dust has settled on that, so everybody's cool now. But desktop applications with Java was a thing on Windows, but it's now more of a thing in the Linux and Unix environments, but it's not really a thing, if you know what I mean. Like, when you take the whole universe of desktop applications, yes, you can see representation from the Java programming language and associated frameworks for building desktops, but you don't see the level of investment in that to the extent that you would see with Windows-based programs that use C# and other alternatives. So I tend to see that as something that's a less salient investment. But Java and web applications, huge in the enterprise, huge in the corporate space, absolutely huge. So Java is great there, but the reputation, which I think is deserved, and yes, there are exceptions. Everything I say in this video, there are exceptions, so you can find them. But in the mainstream and the main threads of how we engage with these tools, the main thing is that Java tends to be a little bit more slow and glacial in terms of how fast you can put solutions together or how quickly you can maneuver and pivot with Java. So it tends not to be a tool that you will use in a startup or a tool that you would use when you're trying to put together a solution at scale with the web, because of the many levers and gears that you need to turn with Java to get a robust, high scalable solution. So if you're looking for a highly scalable language solution, right, then you're looking at C# and .NET Core on Linux, or probably more so, you're looking at PHP. And I say that based on the advancements that Meta, Facebook, has made with PHP, that's going to be in my opinion, your most scalable web application language and framework. And I put the emphasis web application, language, and framework because you could probably adapt PHP for desktops, but it's unlikely to occur. But if you're looking for something specialized for web application development at the scale of billions of users, I would say PHP would be right there, at least a variety that Mark Zuckerberg's team has put out in their contribution to the open source community. So that brings me to JavaScript. JavaScript in desktop applications is possible. It's happening all the time. You have Visual Studio Code. There's this version of Visual Studio called Visual Studio Code. It uses a framework called Electron. And some people like Electron, some people don't. I'm one of the people that don't, but I'm starting to make peace with Electron, right? And so you can use JavaScript and CSS and HTML productively with Electron, and it will save you from having to learn so many different languages, programming languages and frameworks in order to have a solution that works on mobile, works on desktop, and then it's the same code investments that you could use in web applications, right? So that's a productive piece, but in terms of like programs that have great performance, that are tuned well, and that can integrate with the different parts of a system, Electron is probably weak in that area. Now, one framework that I am a little enthusiastic about, if it was more developed, is Apache Royale. Apache Royale, it descends from Adobe Flex, which came from Adobe Flash, which came from Macromedia Flash. And between Macromedia Flash and Adobe Flash, I was an expert in that system at one time. And the absolute best user interfaces I've ever developed that incorporated not only next level graphics design, but also animations right there in the program elements, the visual elements, buttons and borders and different regions of the screen. My most sophisticated programs visually were done in Macromedia Flash and Adobe Flash using ActionScript. So Apache may bring that back, but that project is moving slow right now. And so when we look at JavaScript, right, you have React and you have Angular. And so in terms of like an actual web front end, that's probably the way to go. Even though there's been some talk about WebAssembly. WebAssembly just isn't moving the way that people have expected. And to me, that is a real telltale sign. Then you got Python. Now, Python is controversial for a number of reasons because Python has risen over the last 10 years to become the Swiss Army knife of programming languages. And what I mean by that is you can use Python pretty much everywhere. You can use it to build desktop applications. You can use it to build web applications. You can use it to do scripting in the command line, right? It can supplant Bash, right? And Zish. How do you pronounce that? ZSH, right? All these different shells, right? And it's definitely competitive with PowerShell, right? So you can use Python pretty much universally. But the thing is that you also have a lot of churn with Python, right? And there are issues of style, structure, and approach with Python that I foresee is going to cause some major disruptions in the future. Maybe not in the near term, but when we're talking about long-term technology, I see issues with Python. So, but I do think a person should know Python, invest in Python, and use it in the areas where it's strong. That brings us to Rust. Rust is a newcomer in like the industrial grade, robust, reliable, heavy duty, powerful, high performance software programming languages. When you can convince Linus Torvalds, the creator of Linux, who don't want any other programming language touching the Linux kernel other than C and assembler, to actually adopt your language, you know you're doing something right, doing something well. But I wouldn't touch Rust myself. And the reason being is that the things that you can really use Rust for, outside of just making underlying system foundations, right? The maturity is not there yet to place bets on Rust. And some of the controversies that the Rust Foundation or community, the official parts of that community, has gone through in the last couple of months this year, they may, get past that. But when one of their major keynote speakers ends up having some issues, right, weeks or a day before the conference, you got some work to do. So I'm gonna move on from Rust, and I'm gonna wrap up by talking about C++ and C. So if you look at all of my videos and my blog posts for the last 10 years, you'll see that in my private projects, I spend a lot of time with C++ and C. And what I want to say is that doesn't mean I am an advocate for those languages, nor do I actually agree with those languages or actually like those languages. I actually like the style and flavor of C# a whole lot more. So if I was to not beat around the bush and just tell you like what my favorite is, I like C# on its own merits, right? Independently of where it came from and who it came from, I like the design of C#. But for my long-term projects, for the things that I'm going to bet a lifetime on, right? I'm going to bet on C++ and C. And while I don't like the flavor of those languages, I don't let that get in the way of what I think I'm going to gain from those languages, what the long-term best interests are that I'm pursuing using those languages for my private projects, right? Because those two languages alone have already proven that they are the right languages for innovation, for transformation, for manifesting and bringing into existence your ideas, no matter what they are. When you talk about Unix and how Unix has been foundational for computer science and foundational for systems design, IEEE, the Institute of Electronics and Electrical Engineers, I was an associate member at one point. I tell you what, these mosquitoes are starting to tear me up. They define their POSIX standards, POSIX, their POSIX standard on Unix, right? And Unix was defined in C. If you look at all these big-time software applications that inspired other programs like Photoshop, Adobe Illustrator, QuickBooks, AutoCAD, Microsoft Office itself, right? Windows itself. That whole enterprise is defined fundamentally in C++ and C, right? So it's like, you don't want to ever kid yourself. If you're going to make something that's real and something that's going to be like the real deal, then I'm saying, hey, yeah, you can make the excuse that, oh, they only use C++ and C because that's what they started out with back then. The way I look at it, if that's the case, well, then why don't you just go ahead and convert your big-time programs over to some other programming language that's easier to work with, write with, maintain, tune, and find employees for? Nobody does that. And you can make economic reasons for why you wouldn't do that. I don't buy it. I don't buy it at all. Not when you define Microsoft Teams and Visual Studio Code and Electron, right? but nobody's really betting the future on those things. And so it's like the real core technology is fundamentally defined in C and C++. And if you're going to put a scripting veneer on top of it, you're going to use Python and JavaScript. So those are your 4 programming languages right there. And so C++ for desktops, C++ for desktop programs, that's already an established thing in terms of what has been produced. But in terms of frameworks for Windows, Microsoft has their own tools for that. In the Linux world, the key tools for that would be GTK, GTK-MM, which I'm going to get back into, and KDE. KDE is fundamentally C++. GTK is C, and GTK-MM is C++ on top of C, right? So that people who want to use C++, because C++ tends to be very productive in terms of an object-oriented approach to putting GUIs together, then that would be one way to go about that. And then C++ for web, C for the web. Well, they build web servers, web server technology using C. Why couldn't it be used for building web applications, right? Well, there's some good reasons for that, because a bad pointer will bring down an entire server system, and you can lose your business that way. But if you had a very competent way of using C and C++ for the web, you would absolutely end up with the fastest web applications in the world. So anyway, that's pretty much the overview on these programming languages. Feel free to rewind, go back, look at some of these parts, these discussion points, because in my viewpoint, that's the overall picture on the programming languages, the innovation, and how the technologies are situated in a ranking system in terms of selection, what you would select and what you would prioritize. So I'm gonna head up out of here, see if I can get these mosquito bites addressed, and I will chat with you later.